Welcome to Bodhi Unified Flow. I'm Dr. Mari Muthu, your host, and here we simplify complexity and amplify performance. Today we are jumping right into a monumental explainer on best practices during the design phase, specifically constructability reviews. We're going to break down formal 30, 60, 90 reviews, mapping out early logistics, standardizing with off-site DFMA, and finally, validating your designs for long-term maintainability.
All right, let's look at the agenda for today's explainer. We'll start with the constructability paradigm, then move through the 30, 60, 90 protocol, early logistics and temporary works, the DFMA shift, and wrap up with design for maintainability. By the end of this session, you'll have a really solid grasp on the financial impact of early constructability integration. You'll know exactly how to apply those 30, 60, 90 milestone gates, coordinate your site logistics, leverage DFMA for ultimate predictability, and validate long-term maintainability using the FAME principle. Let's get right into it.
Section 1. The Constructability Paradigm, moving from reactive to proactive.
Right now, the entire capital projects industry is shifting. We're moving away from those old, siloed, traditional design methods and moving toward highly integrated, proactive pre-construction. And why? Well, it's all about the financials. The Construction Industry Institute actually shows that applying construction knowledge during early planning gives owners an average return on investment of 10 to 1. On top of that, it drives an average overall project cost reduction of 4.3%. In our industry, where margins are razor thin, numbers like that are an absolute game changer.
So, the crucial takeaway here is this. Catching a design flaw during the pre-construction phase is exponentially cheaper than trying to fix it once active construction starts. Industry data shows that the cost of a change escalates by 10 to 100 times out in the field, compared to just resolving it on paper or inside your BIM model. Seriously, 10 to 100 times. That metric alone justifies every single hour you spend rigorously reviewing your designs before the very first shovel hits the dirt.
Moving on to Section 2. The 30, 60, 90 milestone protocol, hard gates for design progression. These incremental phases aren't just checkpoints, they are hard gates. At the 30% milestone, we lock in the strategic baseline. We're validating big picture stuff, schedule, budget, and geometrics. Then at 60%, we hit constructability verification. This is the absolute sweet spot for value engineering and fixing utility conflicts while changes are still cheap. Finally, at the 90% milestone, we do the bidability review, verify our final quantities, and ensure we are 100% ready for permitting. This phased approach guarantees that strategic errors simply don't make it into the final contract documents.
But here's the thing, who actually needs to be in the room during these reviews? It cannot just be the designers. You absolutely need experienced construction personnel at the table. The construction superintendent is your eyes and ears. They look at a blueprint and instantly spot schedule bottlenecks or safety hazards. Simultaneously, your estimator translates those 2D plans into buildable reality by pricing labor, materials, and risk right from the jump. You need both perspectives.
Section 3. Early Logistics and Temporary Works Interface.
We often focus so heavily on the permanent, finished structure that we totally forget a basic truth. A project's permanent success is directly determined by the temporary systems that enable its construction. Effective logistics has to begin early. You need a rock-solid traffic flow strategy for safe routing, material management for laydown yards that actually align with your installation sequence, temporary utilities running on day one, and a really strict waste removal plan.
And right alongside logistics, we have temporary works. Think about shoring, scaffolding, formwork, crane bases. These elements carry massive structural and safety risks. Best practice dictates that temporary works must be treated with the exact same rigor as the permanent structure. This means appointing a temporary works coordinator, or TWC, early in planning to strictly manage formal permit-to-load and permit-to-strike procedures. No cutting corners here.
Let's move to Section 4 and see how this builds. Standardization, modularization, and the DFMA shift.
We are talking about a complete transition from traditional stick-built construction into a real manufacturing mindset. And at the core of this is DFMA, Design for Manufacture and Assembly. It basically prioritizes manufacturing component parts in a highly controlled off-site environment and then assembling them incredibly efficiently on the actual job site. DFMA is the absolute foundational prerequisite for any modern methods of construction.
Now, what's really interesting is how DFMA breaks down into 4 highly actionable principles. First, simplicity, using minimal parts and snap fits to drive down assembly costs. Then, standardization, relying on common, off-the-shelf components so you don't have a massive, unique inventory. Next is modularity, creating interchangeable subassemblies that allow for scalable mass customization. And finally, accessibility, designing parts that are just plain easy to reach, which reduces your labor hours and makes future maintenance a breeze. When you pair these DFMA principles with factory flow mapping, basically designing modules around a standardized grid, the economic benefits are just staggering. By moving the work off-site, you eliminate weather delays and height risks entirely. But look at this. Throughput can literally increase by 2 to 5 times, and cycle times can be slashed by 30 to 50%. That level of predictability, that is the ultimate goal.
But, and this is a big but, modularization introduces zero-tolerance technical constraints, especially when it comes to transportation. Depending on where you are, the limits are strict. North America standard width is 8.5 feet. In the UK and Asia, it's capped around 2.5 meters. Unlike traditional construction where you can kind of just fudge a field adjustment, a modular mismeasurement of even a single inch can result in denied transport permits, failing to clear a bridge, or causing a massive safety hazard. Precision is everything.
Section 5. Design for maintainability, integrating operations.
Fast forward decades into the future, a facility has to operate, be cleaned, and be repaired for a long time. If you ignore maintainability early on, your operational costs will skyrocket. So to integrate operations into design, we use the FAME principle. F is forecast maintenance. Make upstream provisions for downstream impacts. A is access. Make sure there is actual working space. M is minimize interventions. Select durable, climate-appropriate materials. And E is enable simple maintenance. Use those standardized DFMA components so replacements are simple.
Let's get really specific for a second. Validating maintainability requires strict geometric rules during the design review. For instance, if you want safe facade cleaning, design protrusions and ledges must be kept under 600 millimeters. Otherwise, you're just creating inaccessible nests for debris. Same goes for mechanical and electrical facilities. Components have to be immediately accessible. You need a primary maintenance zone where test points and fluid indicators are within 45 centimeters of the machine's side. Now this is where it gets really cool. We have incredible digital tools to validate all of this. By using immersive tech like virtual reality and augmented reality, facility managers can literally do virtual maintainability validation. Before a single drop of concrete is poured, personnel can throw on a VR headset, walk through the simulated BIM environment, and physically check if they have the clearance to replace a motor or bring in a cleaning gantry. It lets you test your standard operating procedures in a totally risk-free space. Section 6. Summary and references. So what did we cover today? Well, we successfully validated the massive 10-to-1 ROI of early constructability reviews. We walked through mastering the 30, 60, 90 milestone gates, knowing exactly who needs to be in the room. We locked down the importance of logistics and temporary works. We completely embraced the DFMA manufacturing mindset for better throughput. And finally, we applied the FAME principle to ensure lifecycle maintainability. And of course, the frameworks we've unpacked today aren't just theory. They are the backbone of industry best practice. They come straight from the heavy hitters, the Construction Industry Institute, the RIB Clan of Work, the American Institute of Architects, the Lean Construction Institute, and ACE International. These are proven, battle-tested methodologies. I want to leave you with a final, provocative thought to take back to your teams today. Ask yourself, is your next project merely buildable on paper, or is it truly constructible, modular, and maintainable in reality? Because the difference between those two outcomes is entirely determined by how rigorously you manage your pre-construction phase. Thank you so much for joining me on this explainer. I'm Dr. Marimutu with Bodhi Unified Flow. Apply these paradigms immediately and watch your performance amplify. Until next time.